today, because learning must continue, we are going to discuss today another exciting topic in general mathematics. And I am Engineer Alexander F. Santos Jr., a senior high school teacher in Simisatlag, Division of City of Malolos, your teacher facilitator for this learning session. For this session, our lesson is about representing real-life situations using rational functions. For our objective, at the end of this lesson, you will be able to first review polynomial functions and to represent real-life situations using rational functions with LC code M11GM-1B-1. To start our discussion for today, let us first review what polynomial functions are. So what does this definition mean? It means that for any function to be considered a polynomial function p of degree n, it must follow this general format, and this general format must have these characteristics. What characteristics are these? First, the coefficients or the value of a sub 0, a sub 1, and up to raised sub n must be real numbers. So it cannot be an imaginary numbers. Also, the coefficient of the term with the highest exponent must not be equal to 0. N. What is n? N is the value of the highest exponent of the variable. For it to be considered a polynomial function p of a degree n, it must be a positive integer. Let us consider the following examples. Which of the following are polynomial functions? To show if these functions are polynomial functions, all we have to do is to simplify this function and transform them into the general form of the polynomial function. Therefore, as we can see, this function f of x, because it has a variable with a positive integer, therefore, it is a polynomial function. Letter B is g of x equals to negative x multiplied by quantity x squared minus 4. Just like we have done in letter A, all we have to do is to simplify this function. G of x is equal to negative x cubed plus 4x. Now, let us look at this if this is a polynomial function. First, it has a variable with a positive integers. Next, sir, I can see any constant. Yes, there is no constant, but that doesn't mean that this is no longer a polynomial function. Because according to the definition, a polynomial function where its coefficient must be real. That's the only characteristic. It should be real. Therefore, a positive 0 or a plus 0 is a real number. Therefore, is a polynomial. And for the last given, h of x is equal to 5 square root of x plus 2. If we are going to transform this radical format into an exponential format, it will give us 5x raised to 1/2 plus 2. Therefore, if you are going to look at this, n now is equals to 1 half, which is not an integer. This is not a polynomial function. Now that we have already discussed what polynomial functions are, we are ready to discuss our main topic, which is a rational function. What is a rational function? By definition, a rational function is a function in the form of f of x is equal to p of x all over q of x. In short, as you can observe, it must be in the form of fraction, a form of ratio. That is why it is called rational function. Where p of x and q of x, what are these? The term in the numerator and the term in the denominator are polynomial functions. Also, q of x or the polynomial function in the denominator should not be a zero function, meaning it should not be equal to 0. Why? Because if q of x becomes equal to 0, what will happen to the whole function? It will be undefined. Therefore, q of x or the function in the numerator or denominator rather should not be equal to 0. Also, it must also be take note that the domain of f of x or the domain of this rational function is all values of x, where q of x is not equal to 0. To deeply understand what rational functions is, let us consider this example. So, as you can see from this example, it is in the form of q of x, p of x over q of x, because it has a numerator and a denominator, and it is presented in a fractional form or a rational form. Another, is the numerator a polynomial function? Another, the denominator also has with the term with the variable with a positive integer. Therefore, the numerator function and the denominator function are all polynomial functions. Another we must consider is the denominator function a zero function? No. Therefore, this given function is a rational function. Now that we know what rational function is, let us now represent this function into real life situations. To show that, let us consider some example. For example, number 1, let us represent rational function in real situation using a velocity problem. To read the problem, an object is to travel a distance of 10 meters. Express velocity as a function of travel time in seconds. From the given problem, we are asked to create a function wherein velocity will be represented in terms of time. So how are we going to do that? First, we must recall that the formula velocity is equal to distance over time. Therefore, from this formula, all we have to do is to substitute all the given from the problem. From the problem, it was stated that the velocity will be represented or written as v of t. From the same problem, it was stated that the distance is equal to 10 meters. Therefore, v of t is equal to s. What is the value of s as given in the problem? 10 over t is as is. So, the function of velocity in terms of time is written as v of t is equals to 10 over t. this will be the answer. After representing using velocity problem, let us now represent rational function in real-life situation using a drug concentration problem. Suppose that C of t is equal to 5t all over t squared plus 1, which is in milligram per milliliter, represents the concentration of a drug in a patient's bloodstream t hours after the drug was administered. Construct a table of values for C of t for t equals to 1, 2, 5, and 10. Round off answers to 3 decimal places. Use the table to sketch a graph and interpret the results. From the given problem, it was supposed that the concentration of drug in a patient's blood is represented by this function. C of t is equal to 5t all over t squared plus 1. So, from this problem, we are asked to create a table of values and after that, sketch that table for us to see how the graph will behave. So, from this particular problem, all we have to do is to substitute or evaluate this function using the given values of time. So, this is just a simple evaluation of function. So, first, let us get the concentration of drug or the C of t when the time is 1 hour. For time equals to 1 hour, C of t is equal to 5t. So 5, what is the value of t? 1 hour. 5 times 1 all over t squared. What's the value of t again? 1. So this will become 1 squared plus 1. Okay? So, next is to simplify. So, C of t is 2.5. Next step is to follow the same procedure that we used for t is equals to 1 hour. Okay, so for us to easily compute for the value of C of t for 2 hours, 5 hours, and 10 hours, let us use a calculator for us to easily evaluate the given function. So, to use a calculator, all we have to do is to type the function in the calculator. First is click fraction. So, from that, you click the value 5t in the calculator. So, if you are going to observe your calculator, there is no letter t. Usually, in the calculator, what we are using is x. So, if you are going to observe the calculator, x is found at the top of the closed parenthesis. Therefore, all we need to do is click 5 and press alpha close parenthesis. And then click downward arrow, type t squared plus 1. How are we going to do that? Click alpha closing parenthesis and then the x raised to box. You press 2. So you can see x squared. And then you click right arrow, you press plus and then press 1. So as you can see in your calculator, it is written 5x all over x squared plus 1. So what are we going to do now? All you have to do is to press calc. And then, the calculator is asking for the value of x. So, yung tinatanong na x is also the value of t that you want to get. First, let us try for the value of 1. For us to check if 2.5 milligram is correct. So, let us click positive 1. You click 1. You press equal. It gives you 2 over 5 And then click S arrow D. It is 2.5. Correct? Okay. After that, the formula is still stored. So the next thing that you need to press is calc again. And again, the calculator is asking for the value of x. So you click 2. And then press equal. The value is 2. That is the answer. That is the shorthand method using calculator for solving this evaluation of function. Okay, again, calc, meaning calculate the function, and the calculator is again asking you for the value of x, so the next value is 5. Click number 5 and equal. The value is 25 over 26. You clicking S arrow D will give you 0.962. Again, do not click anything but click calculate. And then put the value 10. Then equals. The value is, the answer is 50 over 101, or again, press S arrow D. It will give us 0.495. So, this is how to solve a table of values using manual computation and using calculator. So, after we have created the table of values, the next question that we are asked to do is to sketch a graph representing the rational function given. So, create a graph using a Cartesian plane. So, a Cartesian plane, we need to have two axes, which are the x-axis and the y-axis. For x-axis, let us use t as our horizontal values. And for y-axis, let us use C of t, or the concentration of drug on patient's blood stream, as our vertical values. Let us put calibration. Let us put from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. And for y-axis, let us also put 1, 2, 3, 4, 5, 6, so on and so forth. So first, let us grab the point for T1 with a corresponding value of CT of 2.5. So because these are all positive values or numbers, this will be plotted on the first quadrant of the Cartesian plane. So all we have to do is to count 1 to the right, because the coordinate of the ordered pair is 1, and let us count 2.5 upward. So 1, 2, then 2.5 is between 2 and 3 at the middle, so 2. And then we now plot the point. So after plotting these points, we are now ready to draw or sketch the graph by connecting these points. So let us connect these points. And after connecting these points, we can see that the graph is what? Decreasing. So, as you can see in the given problem, rational functions can also be used to represent drug concentration on the blood of a patient. For our assessment, try this real-life situation representing rational function using an engineering-related problem or an area perimeter problem. A fence is to enclose a rectangular vegetable farm with an area of 400 square meters. If x is the length of one side of this fence, there are two questions. Find a function p of x representing the perimeter of the fencing material required, and find the perimeter of the fence if one side has length of 10 meters. Pause this video to give you enough time to solve for the problem. After solving the problem, let us check if you got the correct answer. In letter A, we need to create a function p of x representing the perimeter of the fence. So, how are we going to create a perimeter function? First, we need to recall the formula for perimeter for any rectangle or rectangular plane. We all know that perimeter, so using p of x as a representation, is equals to 2 times the length plus 2 times the width. So, according to the problem, the one side of the rectangle is represented by x. So, let x be equal to L. From this given, how are we going to create a perimeter function? So, by substituting this, all we can have is a p of x equal to 2, because L is equals to x, it will become now 2x plus 2w. Going back to the problem, it is said that the rectangular vegetable farm is 400 square meter. So there is a given area. So the given area is 400 square meter. We all know that the formula for area is length times width. So, substituting the value of A, which is 400 square meter, so 400 equals L. What's the value of L? According to the problem, one side of the rectangular plane is x, so we use x, and then W. How are we going to create a function in terms of x? Using this, we multiply both sides by 1 over x. By multiplying both sides by 1 over x, on the right side, x will be cancelled out because x times 1 over x is 1. So this will give us w. And then from the other side, 1 over x times 400 will give us 400 over x. Let us call this equation 1 and this equation 2. So substituting equation 1, equation 2 into equation 1 will give us p of x equals 2x plus 2 times, because this is w is equals to 400 over x, 400 over x. Simplifying this will give us p of x is equal to 2x plus 800 over x. And to give us a rational function in the form of, again, what is the general form for rational function? The general form for rational function is what? F of x is equals to p of x over q of x. So how are we going to do that? How are we going to combine these two terms? So by finding their common denominator. Least common denominator of this and this is x, because the denominator of 2x is 1. So computing this, x divided by 1 is x times 2x will give us 2x squared, and x divided by x is 1 times 800 is equals to 800. Therefore, our perimeter function for the fence is p of x is equal to 2x squared plus 800 all over x. So now that we already have a perimeter function for the fence, which is 2x squared plus 800 all over x, we can now compute for the question letter B, which is we are asked to find the perimeter of the fence if the length of the one side is 10 meters. So the length of the one side is 10 meters. So how are we going to answer this? All we have to do is to evaluate the function or to substitute the given value of x to the given function. Therefore, p of x is equal to 2 times, what's the value of x? 10. 10 raised to 2 plus 800 all over x. What's the value of x? Another 10. So, simplifying this will give us of the fence is what? 100 meters, not square meter. Why? Because square meters is only used for area. Because this is just a perimeter wherein you are just adding the distance or the length of each side. The unit for this is meters. So the answer is 100